Hello, my name is Doug, and I'm a visual effects artist living in Berlin, Germany. And I'm here to just give you a very brief overview of a procedural Houdini project that I worked on for a while. Let's get started. Okay, so what do these two images have in common? What they have in common is that they reuse a common principle, which is the circular arc. And that's what we're going to have a look at. You might have watched a couple of my previous Houdini videos, and if you did, you'll find that I really like these kinds of arcs, since we find them everywhere in architecture and engineering and stuff. Now, in Houdini, we can create and we can work with circular arcs by using geometry directly, copying it onto points and stuff. And I've done that in the past, but it's not always ideal, and it's not really what I wanted to do with this project. What I wanted was the ability to simply build or construct an arc between two predefined points in space, anywhere in space. And I couldn't really find any good tools or functions that does it out of the box, at least not that I'm aware of. So my solution was therefore to simply build something myself. What we need are 2 points, a center position, and 2 vectors. One vector that basically defines a normalized ray from the center of the from the center to the 2 points, and another one that you can think of as an up vector, which is perpendicular to the first one. One thing we need to think about is that because we want a circular arc, that means that the distance between the center and both points has to be equidistant. Otherwise, it won't work. Okay, so the center is important, we know that, but what is the best way to define it? I used a mathematical formula and then Vex code to do it. There are other ways, but that's what I chose. And what that is, it's an intersection calculation. It's an intersection analysis. And we can use that to find our center point based on the vectors that we already have. One thing to note is that the 3 positions that we've got, they're going to define a plane in space, which we can then later on use to make our solution robust. Let's look at a very basic way to create this arc. We just need a primitive, we need our 2 points, and in this case we also have a center. We are going to do some pre-computation in a point triangle to find the correct vectors that we need. And then in a primitive wrangle, we're going to run the actual code that does the arc itself. And you're going to see that code on the right in a second. Here you can see everything works fine. We can move the center and the arc moves accordingly. So everything looks good. So in the next example, it's also a very basic example. We use this geometry for our purposes. We're going to steal some points and some normals from it. And then we're going to run this code now on multiple primitives. But this time I created a tool for it. And this tool has a lot of other functionalities, like you can determine the frequency of points, you can flip the things, you can also determine which angle you want to use, the small angle or the large angle. We've got circumcircles, etc., etc. So now it's getting a little bit more useful. One thing that we need to test is if it's actually stable and working well in 3D, which we can see here that it actually does. So that's really nice. That's a good confirmation that our stuff works. And then we have a more practical example. We still use the same principle, but this time I've changed it to create a tool that essentially creates these architectural arches. We have 1, 2, 3, and 4 centered arches, so we can create a whole variety of styles with this if we want to. As we can see here, we have an example of a 3-centered arch, and here you can see how the centers actually relates to the arcs that are in that construction itself. It's quite nice. And if we expand on that, it won't really take too much effort to come up with something like these type of Roman-style arches, like I don't know, an aqueduct or something. This is a bit contrived, this example, but of course, I hope you see that this can be fairly practical. Okay, great. Now, let's have a look at something else. Again, we're using the same tool, This time we're creating some Gothic style arches, and then we keep building on that until we have a basic cage. From that, we really only need one section that we're going to give a lot of ribs, and then we can create a surface from that, so that when we then copy that, we are starting to get somewhere. And then we can use that geometry itself to keep on basically procedurally create all the other elements that we need for this. We need a keystone, a base, we have those curves, so with those we can actually create the ribs, and then we have one section of a ribbed vault. And then when we multiply that, when we copy that, then we have many. And then here again, as you can see, we're using that same tool, this time to create windows, so that we are now essentially constructing piece by piece a little interior set that we can then texture, and we can shade it, light it, and render it. And then here are some extra light fixtures that I also created, again, also using those same tools. Nice. Now, finally, let's look at this image here, this project. And for a long time, I really wanted to build a system where you take a simple incoming polyline and you kind of replace the corners with the arcs that I'm looking for, that we've been creating until now. And you might ask yourself, can't we just do this with some very simple workflows or out-of-the-box tools in Houdini? And I think that the answer to that is that it depends on your needs. And I found that for what I wanted, a custom solution was just a lot better. So let's look at how I solved this conundrum. Again, we want to turn the sharp corners into curved corners, and they should be circular arcs. And if we just convert stuff, we can right away say that's not really going to work for us. It's not going to give us what we want. The curve tool does have a feature called rounded corners, which is really nice, but it's actually far too manual for what I wanted, and it only works on Bezier curves. Okay, procedural solutions then, they give you sometimes good results, but they tend to break down in the really sharp corners, and they don't really give us the actual circular arcs that I was looking for. So I made the custom solution. And here, of course, we do get circular arcs, and we have some very nice control over how they're implemented on our curve. So we have, for example, a global offset, and then we also have angle-based curvature offset that you can see me playing with right here. So that means that we can determine where we should have more offset and where we should have less offset, depending on the angle of the incoming curves. Then we also have a nice little feature here, which is that I made it so that we can export a turn direction attribute. And that's going to come in really handy just in a minute, as you'll see. But we also want to make sure, of course, that the solution that we're building when we're doing these kind of things, that it actually works in 3D and not just on a flat plane. Okay, so how does the logic actually work? Now, the first thing we're going to need to do is we're going to identify the turn points, because some of our incoming points might not qualify to be a turn. And then the next thing I did after that, you'll see that in a second, was that I chose to do a sort of vex-based carve from the turn points inwards, as you will see here. And now we can say that we basically have the original point positions, they're known. The new carved point positions are known. So that means we won't really have any issues when we want to create a vector that points towards the old known position. And as you can see here, this will give us an orthonormal plane, which will help make our solution robust. And again, we won't really have any issues then creating these two needed vectors that we're going to need for the arc. And let's just call them the normal and the up for simplicity. We can split the geometry into the pieces that need processing and the ones who don't. We do our intersection analysis that I showed you earlier to find the center. And that basically means that we have everything we need to create the arcs. So we do them, and then we can bring everything together do point sorting and whatever we need, and we have a solution. And this will be sort of the backbone then for the road that we saw earlier. All we're going to need to do is a sweep and get ourselves that surface, like here. We see a road, or we see a surface that we can interpret as a road at least, but there's a little bit more to this. Remember the curve direction attribute that I showed you earlier? Now it comes in handy because it will allow us to do banking of these curves. And you'll see it a little bit easier here, visualized. And with this attribute, we can make sure that the curve and the road, therefore, will bank in the correct direction, depending on the turn. I also built in another extra, which is in tight corners. This is angle-based. We can offset and flare the road a little bit. So if this would be a real road, it would give cars a bit more space in tight corners. Okay, so let's finally move on to the practical road example, where we're going to start with a simple height field from Gaia and a base texture. And yeah, you can see here that I'm switching. Basically, I'm downsampling the height field just to have a bit more speed in the viewport. And then I have a whole stack of masks here that we can use for texturing. And you'll see that we're basically separating them out, putting them into a copnet, and where we can do a final texture for the road, or for the entire thing. Then we see the incoming curve, and we use our tool to create the circular arced corners, and then the banking and everything. Sweep, so we have a surface, and then we have another COPS node here to create a procedural texture, so that we have something that looks a bit like a road. And you can see that the road is elevated, it's not just a flat plane. But here's the interesting part. How can we integrate the road into the height field itself? We start with a mask based on the geometry. We expand it and blur it so that we have a transition. And then we're just going to do a few lines of Vex code, as you can see here. That's really all you need to make the road kind of imprint into the landscape. So now the height field is following the road surface where we have that mask, as you can see here when we see the overlay. And that was actually very simple to do. So here, again, now we're making a few more masks, and out of our copnet now comes an updated texture. So where we had the masks, we now have a different kind of texture. If we want to view this with the actual road together, we should convert the height field into basically a proper polygons. And then, as you can see here, we have some jaggies. Some jagged edges there. That really is only because of we downsampled. So if we're now watching the whole thing with the original size and resolution of our height field, things look a lot better. So here I'm switching it off so we have a bit better feedback to see that this is all live and will update live. I mean, it's not the super fastest in the world, but there's also quite a few things going on behind the scenes. Everything is updating live, as you can see, both the road, the texture, the height field. It's all live. And then we can switch back to like the full res version to have a final view of things. Things are looking quite nice. And after that, I think it's time to have a view of a render of the whole thing that you can see here. Right, we're now back to the image that we started the video with in the first place. And that means that we've completed this demo. And if you've managed to stay on board until now, I hope that you too have picked up a few things on the way, and that you can appreciate the power of proceduralism in Houdini. It is indeed a very fun way to work. And of course, if you like this content, do feel free to like and subscribe, and hopefully I will have time to create some more videos for you in the future. And that's it for now, so thank you very much for watching.